So I also have the links here if somebody wants to follow along and with the materials right away. It's on GitHub. And yeah, if you want to know more about me, just go to oliver.bestwalter.de. Everything about me that you could think about is there. So after this, what I hope, the questions that will be answered is what problems do fixtures should solve? Why should I use fixtures? You know, what's the idea behind it? That's like 15% of this hour, hopefully, and more theoretically. And then the main meat of the whole thing is the applied, looking at code, running it, showing you how it's supposed to work, explaining all the ins and outs of fixtures that I think are essential to know. And hopefully Paul will also explain a few things or ask the right questions in the right time, that I don't get lost too much. And then if we have time afterwards, but if not, it's not the end of the world. The links are there, the explanations are there, and the slides already, is how do I find and use built-in or third-party fixtures? And how can I share my custom fixtures between projects? That's basically well-defined problems that are also documented very well. If you can't cover that today, it's not the end of the world. So, and if you will not have liked this webinar, that's future too, then, I mean, Holger Krekel made a really great tutorial that is quite old already. It's from 2014, I think, but it's still relevant. It's still great. And, you know, from one of the authors of the tool themselves, it's a 3-hour tutorial from a PyCon, I think. So have a look at that. It's covering PyTest as a whole. And if Paul did not talk enough during this, then look at his PyTest Fixtures video, which is only 7 minutes long, and then watch the whole rest of this, because it's called, I think it's Visual PyTest. Paul, is that right? Paul, can you hear me?
Sorry, I was on mute.
Ah,
yes,
okay.
it is.
It's called Visual PyTest. Yeah, it's like a video series you made, and that's a really great series. And you have one segment about fixtures, and yeah, that is basically all you need to know, I would say, in 7 minutes. And if that's not advanced enough, what I'm talking about here, then Floris, and he allowed me not to say his last name because I'm not capable of doing this. Advanced uses of pytest, and as you can see also from the title, that is also an older talk before pytest, py.test turned into pytest, but that is still a very good talk which is covering some advanced concepts. And if you're more into the mechanics of how these are implemented, these functions, this functionality, how is PyTest actually implemented and how are fixtures implemented on the language level, on the Python language level, then you can watch my talk from last year, Abridged Metaprogramming Classics, this episode, PyTest. So now we start. And what should we do first? Oh, I have to get rid of this thing here because I can't see what I'm doing. So the history of every major galactic civilization tends to pass through 3 distinct and recognizable phases, those of survival, inquiry, and sophistication, otherwise known as the how, why, and where phases. For instance, the first phase is characterized by the question, how can we eat? The second by the question, why do we eat? And the third by the question, where shall we have lunch? This is from the second book of the Hitchhiker's Guide to the Galaxy from Douglas Adams, and I read the second book first, so I have a problem with ordering things anyway, and I think in teaching there's a problem with ordering things, and this is why I'm mentioning this, because whatever order I choose, it's wrong for a part of the audience anyway. So Douglas Adams seems to think everything starts with a how, and I often start with a how, but yeah, so learning something new is always about why, what, and how. Why should I learn it? What can I do with it? How do I do it? Those 3 things are actually always somehow intertwined, and everyone tends to prioritize them differently, which is why there's no correct order in addressing them. So just go with it. I said that. So let's start with a why. And I'm jumping over these. I have 3 arguments basically why, but as I think I have much more than we can cover in this hour. I won't bore you with the first 2, but there's an analogy which is basically, you know, fixtures in the real world look like that. This is a welding table. So fixtures are not something abstract. It's coming from the real world, the idea. And the idea is always, I want to do something with my workpiece under test, and yeah, and I have help with that. And so this is from the real world also, and this abstract argument, let's not just deal with that. Let's look at that. So if you look at it from the computer sciencey or the design patterns aspect, still have to get rid of some visual distractions here. Okay. The first question we have to answer is, what is the difference between frameworks and libraries? Because PyTest is not just a library, PyTest is a framework. And then we look at what kind of patterns and programming principles are behind fixtures. What are they based on? There was an art installation in 2010 by Birgit Bachler, which was basically a phone booth with a really old-fashioned telephone in there. And when you went in there and went to that telephone and listened to what it had to say, then actually it read things from the internet to you. So I think Yahoo existed still back then, so it read posts from discussion groups from Yahoo. So the internet was calling you. And people looked like this when they used that. So, and that's the main thing you have to be aware of if you think about what PyTest does. PyTest is calling the code for you. That is why it's called a framework. It also provides library functions. I mean, you can say import PyTest and then use functions from it. But the main functionality is that PyTest is running the code for you. So it's a framework. And so I can just write a test. I mean, we know all that. This is not a complete beginner course, but just make this. I like to be Captain Obvious with these things sometimes, to actually really make it very clear in the way we're thinking about it. This is why it works. I can just write a test underscore function, and then PyTest is magically calling this for me when I run PyTest. And so the decision about if and when that function is called is not made by us, it's made by PyTest. And this is an inversion of the control flow of how we normally program. Normally we have our entry points and we call functions and we create classes, objects. So this is inverted. And this is called inversion of control, surprise, surprise, which is one very common programming principle. And fixtures are making use of that, and the PyTest framework is making use of that, this inversion of control idea. And if you want to take this idea a little bit further, this is where fixtures come in then now. What am I doing if I write something here? This is basically what is requesting a fixture. So that's like a magic parameter, because I'm not passing anything in there. I'm not calling it myself. So somebody has to do it for me. That somebody is the PyTest framework. And PyTest can figure out what that actually is and make that connection. So figure out what is it I'm asking for here. So, and this, so we could say that the test depends on an object provided by the tmppath fixture, and that is requested by adding it to the parameters in the function definition. PyTest then injects that request dependency into the test function as part of the test run. This means in practical terms that PyTest calls the test function with a correct argument, the return value of the tmppath fixture function that PyTest also calls for us beforehand. So this is how I have to think about the process, what is happening if I am requesting the result of a fixture function in my parameter list here. And this is also like a well-known programming technique or software design pattern, and that's called dependency injection. Somebody else injects a dependency that I declare in this case, in the header of my function definition. That is just one way this can be done. We will see later on also that there's another way of requesting fixtures that is not using this. Oh, by the way, quick question. Is my mouse pointer visible? So if I show things, is that visible? If I point at things?
Yep.
Okay, great. Wasn't sure. Yeah. So now that we know this, and now, I mean, you have basically, if you're here, you have a vague idea about fixtures already. You might be using them already. You just want to learn more about them. So you have a vague idea already. So if you now look at these three things, and ask yourself, what do they have in common? Context managers, decorators, and fixtures. What do they have in common? There are different ways of addressing the, and I don't know if that's the official name for it, but I just gave it that name, the do something before, do something after problem in different contexts. If you think about it, what does a context manager do? It opens a context, and everything that is in that context manager context is with an active context. And as soon as you leave that context manager context, which means unindenting the code, then you leave that context. So you have that because you need to do something before, for example, opening a file, and then afterwards you need to close it again. And decorators is the same on a higher level. You have a function, but you need to do something before you call the function and maybe afterwards. So you have a decorator for that. And fixtures is exactly the same kind of principle, just for testing. A fixture gives you the possibility to do something before you run a test, or it's all optional. You can only do something before, you can only do something after, or you can do something before and after you run tests. So these three things are basically different incarnations of the same solution to the same problem. But I would say that's enough theory. I said to Paul earlier on it shouldn't be more than 10 minutes. So, and I think I was right. So the first two would have been too long. So let's have a look. What's the goal actually? Really, why am I doing this? Why am I writing fixtures? The idea is really making testing easier for everybody involved. And everybody involved might be people that have not such a deep understanding of, for example, if you're the main maintainer of a project, you know everything inside out, you know how to write tests for it. But let's say you run an open source project and you want to make sure that contributors can write tests when they contribute code. Then you might want to give them a little bit of help by providing fixtures to make testing easier. And one real world example we could have a quick look at is the init.proj fixture of the TOX project. I opened that already here. So that is a fixture. If you want to contribute code for TOX and then somebody from the maintainers say, yeah, that's really nice, that's great, we might add that, but please write a test for it, then you can quite easily write a high-level test by using this init.proj fixture, which is creating a whole little TOX project that you can then test things in. So it creates a folder structure, it creates even a setup py with some generic contents, and it creates other files. So this is doing a lot of work for you that would be very tedious to even figure out what you have to do to be able to making the first step in writing a test. So this is all taken care of, and it's used in many places, and it's very makes writing high-level tests for TOX very easy. So that is part of the motivation, really, why fixtures actually exist. So before we looking into building up what fixtures can do and looking in some details, let's have a quick look at the mechanics of how I would do something similar with normal Python code. So some mechanics, but not too much. Let's say we have a function, and this function, and it's any kind of function. We're not talking tests here, yeah? That's just some function. And this function expects a temporary path. So I have the same kind of thing here. I define a parameter. It's called tmppath, and I do something with it. It doesn't really matter what. Oh, and I have the wrong interpreter now. I have normally Python 3.8, so I can't use that advanced feature. Doesn't matter though. It's a nice feature though. So let's say I want to write something that provides this temporary path. So I can write a function that expects a function as a parameter. And then I create this temporary path by using temp file, for example. Then I call the function. I save the result. then I tidy up, I delete it because it's supposed to be a temporary directory, and I return the result. And if I run this now, then I see the function did something with it. I was provided with blah, blah, blah. And then when I exited again, the folder was deleted because it's supposed to be a temporary path. So, and yeah, I mean, if you think, oh no, that's not going to work, you have to put that in a try finally. Yes, let's make that a bit nicer. Let's use a context manager. So here we have to be doing something before, doing something after. I create this temporary directory, and then I call the function within this context and return the result. And when this is left, so here, then the directory is deleted. And this even works then also if there is an error or something. So same functionality. So what's the difference then to a fixture? The difference is actually not that big. I could do something very similar by creating a fixture. You see, this is basically the same code, only this is a normal function that expects a function as a parameter. And here I write a fixture. So I say at pytest.fixture. So this is the signal to say, PyTest, integrate this function into your run as a fixture and provide that to other tests. I call this tmppath, and I do pretty much the same here as I did before, only that here I'm not calling the function myself because that's what PyTest is doing for me. So all I have to do here is give that path back, and everything I write here is given back to the function. And here I don't have a return, but a yield to make sure that the path is returned, the function is called within this context still. I am still in this context when I do a yield here. And when the function is done, then I basically end up here again and then leave the context, and then the temporary directory is tidied up. So the difference between these two things is really not that big. And now let's have a look at fixtures from the very beginning. So I created some super complicated Paul knows that already. I do always very complicated example code. So I have this example code here. You have some global setting, which is the settings path. So in the home directory, I have .my settings. That is settings for my complicated software I'm going to create. But the first thing I write is the settings. And then I have two functions that help me writing the settings and read the settings. And I just, dump it into a JSON. So whatever I dump in here, so this expects a dictionary, it will be written in a JSON file and will be loaded again. So that's our whole production code that we're going to look at. It's really not that much. And it actually doesn't really matter for what we are doing, but I guess it's clear. Are there any questions about this? Maybe I stop quickly if this is not clear.
Sure. Someone mentioned a question that you then wound up, I believe, answering about the yield and return from or call after. And when you had the decorators and the three ways of doing things, decorators, context managers, fixtures, that yield from is an important thing. If you have a fixture that needs to do some work, and then after it's run, kind of needs to undo that work, you use a yield instead of a return, so you can then get control and do some things after the fixture runs. We had a question about what software are you using to do this magical alien typing in the middle of your presentation thing?
Typing in the middle of the presentation? Oh, you mean this is a Jupyter notebook?
Yep.
So now this is what it looks like normally.
But I thought I'd give you a chance to show what this actually is.
Yeah, this is a Jupyter notebook, and there's a really nice extension that you can install. It calls the RISE extension, RISE, which then gives you the opportunity to, you can say what you want this to be. So this is a slide, and if I then activate the presentation, I can actually have a presentation, but it's just a normal notebook. So I can fix errors there right away, and I can execute code. So does that answer the question?
Yeah, it does, and that handles our questions. So onward.
Okay, so now that we had a look at the production code, let's write some tests for that code and do it without fixtures first. So I need to massage the world a bit, so to say. So I need to set the old path to something else because I don't want to manipulate the real settings path. So first I set my settings path by manipulating that global name in my code here. Manipulate it to show somewhere else, so to fake settings, for example. And then I write something in there, and then I run read my settings. So this is testing reading the second. Then I run my actual function, and then I see if it's the same as the fake settings. And then finally I set back the path back. So I'm doing several things here. I'm manipulating some code in my production code to fake the world for making testing easier, and I create this temporary directory here. And that is, I mean, it's not too much code, but it's already some setup involved, and the actual test somehow gets a bit lost in the noise here. And the same here, and I have to copy that code if I want to test the writing. I basically have to do the same thing, which doesn't have to be bad right away, and maybe I would start off with that also. But then after a while, especially if more tests are growing there, maybe that's not the right way to do this anymore. And you want to modularize that a bit more. So then the second step would be that you use fixtures. And for these things, there are already two fixtures that you can use, the tmppath fixture, which is an inbuilt fixture, and the Monkeypatch fixture, which gives me the opportunity to manipulate any kind of object and change it to something else, and the tidying up will be done for me afterwards. So if I Monkeypatch this here, I know that it will be reset back to the old settings, just like I do it here in this try finally setting. So that's Monkeypatch and tmppath, and now all of a sudden I have very much less code and very much less noise, and the actual test is seen easier also. And I can use this and share my settings also, and can access it from there. So that would be one first test using fixtures. And I have some notes up here. This is something I definitely didn't want to forget to mention. So these are important command line flags to help you figure out what fixtures are available, what fixtures are used per test, and you can even see a whole setup plan. Setup only means it only runs the fixtures. This only shows what would be done, and this shows you while the tests are running. And let's try this quickly to add this to the default configuration. So I could say, like if I'm exploring this, I could Python tests, pytest. I could add this here to additional arguments by default, so that when I run my tests, I can always see exactly the fixture setup. So if we run this here, let's run those tests. So this is the without fixtures. And I see here nothing really, no fixtures were used here. The two tests were run. They're both green. Everything's fine. Nothing interesting happened here. And if we run now the first version of our fixtures, let's see what that looks like. So there we have this kind of plan that we see. So here, test 02 using fixtures is running Monkeypatch. So I'm running the teardown of Monkeypatch and the teardown of tmppath. And if I look at the concrete test, I see actually the setup. So It's a bit fragmented, the output here, I realize. I think maybe if you run this on the command line, you see this all in one bit, but here you see only the setup. So PyCharm is massaging the output for you a little bit. So here you see this, the setup is done before the tests are run, and afterwards the teardowns are done. This might be actually a bit better to see than if you run it normally on the command line. But this way you can always see exactly which fixtures are used. So if you have any kind of more complicated setup and you don't really know which fixture comes from somewhere, which is possible in more complicated setups, this is really a big savior. So now that we have used fixtures in a simple way, let's write our own first fixture. That's also not really that hard. And in that context, I wanted to mention that there's some functionality that PyCharm gives you that is not really part of, you get code completion, for example, for fixtures. And this is not happening because this is how Python works. This is because PyCharm understands pytest. So fixture completion, fixture navigation, and also no false positive warnings that the module level fixture name shadows the parameter. And the possibility to visually debug the tests. These are all things that are possible because PyCharm understands pytest. So if, for example, if I control click here on Monkeypatch, I can navigate to the Monkeypatch code in pytest. That is only possible because PyCharm knows how things work. So if I want to write my own first fixture here, I could say it's not really good to have a module level constant. I want a fixture that provides me with those settings. So I can write a my settings fixture, does a bit of printing there, and then it returns our fake settings. And then I can use this just like the inbuilt fixtures. I'm still using them here, and I just add them here in my list, and the order doesn't really matter either because it's the connections over the name. Fixtures are found by the name. And so I add my settings fixture here. And if I run this, it still works. So that's test 03. Basically, it's still again the same. Only here now I have the setup of my settings also involved and the teardown. And here you can also always see also in which order. I hope it will never play a role in your test in which order the fixtures are executed, if they have the same kind of context, but you can see in which order they are executed. And this is one thing I noticed, by the way, Paul, that's a question I have, quick one. If I control click here on my settings, okay, on Windows it works. If I do that, I mean, I did the preparation in Linux, and when I clicked on here, I ended up, I have one in conftest already hidden away for later on. I ended up in the conftest. So it's maybe I can reproduce that later on and see if that's actually a bug.
Yeah, we have a ticket open about when you've got kind of a nested hierarchy and overridden fixtures and stuff, navigating to the one that you expect. That's a good point.
Sometimes PyCharm gets confused, but here it works. You know, here is actually what I expect. So it works in Windows and not in Linux at the moment for me. Yeah. So if I click on here, then PyCharm realizes, okay, this is my settings fixture that I'm requesting here. So now we have wrote our own fixture already. And wait a minute. Oh, now it opened a completely, it's even worse in Windows, sorry. It opens a completely different file here. And it's interesting though. In Linux, it opens the conftest, and in Windows, it opens another fixture that is using a fixture of the same name. Okay, so there's definitely a little bit of work to be done still. But let's move on. So it finds the fixture here because it's in the same module. And now we wrote our first fixture. So what could we do next? We could depend on fixtures. which means if I don't want to have this monkey patch and the tmppath fixture, because if you looked at it, basically I only needed the tmppath fixture in conjunction with monkey patching my settings. So this is actually one thing I could group into a new fixture and could call this fixture fake settings environment. And in this fake settings environment, I depend on monkey patch and tmppath and do what I did before. So here I'm doing that in my test. And here I'm having a new fixture and I depend on those two and I do the monkey patching here. And I don't even need to pass anything back. I'm basically creating a fake environment here. And I'm using this fake environment in my test without actually depending on any data from it. But I still add it here. And if I run this, still the same is happening. But now I have fake settings environment set up and tore down, tmppath and monkey patch still. And here it might be actually interesting to show quickly. Yeah, it's test 4. I had a terminal open somewhere. Yeah. So if we want to look at, oh damn it. Set up. So if now I called setup plan, which is basically telling me what PyTest would do if I would run it like this. And here I see even a bit more information. Here I see then that tmppath is using a fixture itself, which is called tmppath directory, and fake settings environment, the one which I wrote, is using monkey patch and tmppath. And here you see then also if you run it on the command line, you have this output not torn apart. You have the setup, then the test would be run. That's this part. And here also the test says, I'm using the fixtures, fake settings, monkey patch my settings, request. That is also an inbuilt fixture, which is very interesting. We might have a chance to look at quickly, at least. Tmppath and tmppath factory. So here I can always get a good overview what happens when and why and what uses what. And that is the main thing you should resort to if you get in any way confused in your first steps with fixtures, or if you're doing more complex activities there. These are the tools that you can use then to debug any kind of problems. So now we created like this fixture depending on fixtures. So and this is the same thing. I'm just saying here I need this and this, and then PyTest calls my fixture and injects the dependencies for me. Same principle like in the test, only in the fixture. But as I don't depend on any objects here, I could also say use this fixture, but I don't need any kind of data from it. And this is the way how you would do this. So you say pytest.mark usefixtures and pass in the name of the fixture that you are depending on. Instead of having it here, you do it like this. There's no functional difference. It's just a different way of saying it, and a clearer way here also, because this way you say, I want to work in this environment that this fixture is creating for me, whatever that kind of environment is. May it be a temporary path or a running database or a whole Kubernetes cluster that is being set up somewhere for you. Doesn't matter at all. It's just saying, I need this fixture to be run, but I don't need anything from it. And if you need something from it, like here, then you request it here. I paused quickly and asked if there are any questions about this, because I'm just like halfway through the fixture build up. Or am I going too fast or too slow?
We have about 20 more minutes, so I think you're doing okay on time. I'll keep it quick on questions. One comment,
Okay.
I'm about to paste into chat the 2 tickets about multiple fixtures with the same name and the problem that PyCharm has deciding which one to go to. Question is a good one. It's about setup only, the -- setup only flag. Can you pick the scope of the fixture, such as only fixtures with a scope of session?
Well, we haven't even covered scope yet, which will I do in a second. So,
Right.
but in the context of this command line, you can't pick a scope as part of this command line invocation, as far as I know. I mean, I'm always using this just to get an overview what is used without any. I don't think there are any extra qualifiers you can add there, so you can just
So you
get the
cannot.
overview completely.
Okay, good.
No, I don't think
you.
so. Yeah.
That's it. Continue.
Yeah. Yeah. Okay. And whoever wonders now what a scope is, we'll cover that in a second. So, but this is the difference between depending on an object and just depending on a fixture that we had a look at here. And then the question, how are fixtures found? I mean, we had this quite fuzzy until now, and I tried to come up with some kind of memory help because I appreciate this LEGB, if you know that from the Python, how Python name lookup work. If you look for any kind of Python name, wherever you are, if you're looking for a name, for example, if you're in a function here, first the local namespace will be searched for the name, and if it's not found there, then the enclosing namespace. So if I have a closure function, the outer functions will be searched for the name, and then the global namespace, which is basically the module namespace here, and then the built-ins. So that is the lookup order for Python names. And the same principle you have for pytest fixture names, only it's cmlib or cmlib, which is class. So if you have a fixture defined in a class, because you can also bundle fixtures in classes, just call them test something and put test functions methods in there, and then you have tests bundled in a class. This is found first or in the module. So in this case, for example, if I have a tmppath fixture here, so I'm overriding the inbuilt tmppath fixture. This would be found first for tests in this module. Although there's an inbuilt tmppath fixture that we already used before, this would be found first. And then there is local plugins, which is basically conftest.py. And I did this with my settings fixture here. So I took it out here and I put it in a conftest.py in my test folder. And this will be found there now. So this ends up being found in the local plugins. A conftest.py, you can think about conftest.py as a local plugin, and creating a real plugin, the gist of it is really just taking this code out, taking this conftest.py out, putting it in an installable package, and install this and use the right name for the entry point. Maybe we can have a look at that already later. So that's the local plugins, and then there are the installed plugins. And then last but not least, the built-in fixtures. So that's the lookup order you always have to have in mind. And if you forget, then run setup plan, setup show, or debug the test, and then you will find out what was found and what your wrong assumption might have been maybe about the order of lookup. But I think it's quite intuitive, actually. So what I did here is I moved something into a conftest.py and I override the tmppath fixture with a local fixture. And if I run this now, it's still the same test, nothing interesting happens here, still doing the same test. If I run this should still work. But what was used now, and we would see that if we would do the more verbose thing, that's also something I wanted to show at least once, the fixtures per test. So here in the first file, there's always like a cheat sheet. So fixtures per test is also something that is interesting then in this kind of context. Which file were we? We were in fixtures lookup, which is 06. And then do fixtures per test instead. So here you can get a really detailed overview then in which fixture is exactly used in what test and where this fixture was found. So this is super for debugging also. So here you see that my settings, for example, now was found in conf_test_py and not in that module. So this is also a really nice way to debug these problems. And there's one thing I just remembered, Paul, you're telling me, which I also think is really basically a good idea. The idea of always running your tests. I mean, if you're working on it like that, always running them through the debugger. So in case something goes wrong, you see it right away. So if I run this through the debugger, I can then step through the code. I can set a breakpoint in the test directly, or if I'm not sure, let's stop that again quickly. If I'm not sure where I'm ending up, I could set a breakpoint here and see if I end up there. And here I don't end up there because I was using a different file. It was O2, which didn't use that fixture. So if I run O2, the breakpoint isn't hit. And if I run 06 through the debugger, the breakpoint is hit. So now I'm ending up here in my conf_test picture. So all the normal tools that you have at your disposition, debugging normal code, so to say, you can also use when working with tests and working with fixtures when you're trying to figure out what's going on.
One small point on that,
So that
the upcoming PyCharm 2020.2, if you run your test under the debugger, you don't even have to set a breakpoint. It will stop when an assertion fails and give you a friendly little inlay telling you what happened.
Oh, nice. And also a consoler, where you can then inspect what's going on.
Right.
It's always opening. Yeah, that's also really nice. Yeah, so that's very handy. So that's lookup. CMLib. I don't know if that will ever catch on, but I think it's quite nice little acronym. And these are the most important basics, and this is why I want to talk about how to shoot yourself in the foot with fixtures quickly, especially if you're getting more into the depth of it now. So usually interesting bugs are usually an unfortunate combination of wrong assumptions playing together in a way that it might seem like things work fine on first look, but they don't. That's my experience, at least. So what is really important also when you're writing tests, especially if you're starting to write fixtures and it's getting not completely trivial anymore. I mean, there are these two camps of test writing people. I have to at least talk about this a little bit. There's one extreme says, do everything in your test and copy code around like there's no tomorrow. Every test should tell the complete story, all the setup, all the teardown, everything you do should all in the test. And if you end up then with very verbose tests, that's no problem. That's one extreme. And the other extreme is, and that is more like where the PyTest camp is, I would say, and that's why fixtures exist, is try to deal with your test code just like with normal code and try to think about reducing code duplication and modularization and code reuse and all these things. These are just the same. They have the same value for test code, just like for normal code, because test code is normal code. But yeah, this has downsides because, I mean, you can end up writing test code that is very complex then, or fixtures that are very complex. And you have to make sure that they still do what you think they do. And if you get to a stage, which I noted down here, testing your tests, I mean, this is definitely when you should maybe question if things got a little bit too complicated. But the main safeguard against this is that you always check your assumptions. I mean, tests are basically just an executable way of checking your assumptions against the production code. And if you have fixtures, you can also check your assumptions. And you can put assertions in your fixtures, for example, just to make sure that the universe is in the right shape that you're expecting. So you always use assertions to verify important assumptions programmatically, also in fixtures and tests. I mean, in tests, the assertions, they belong there normally, but in fixtures, they also have their place. And one important detail I didn't want to forget to mention is that if something goes wrong in a fixture, that is not a test failure, that is shown in a different way, that's an error. So, and that's also an important and helpful distinction. So, and knowing this, let's have a look at some problems one can create for oneself. So, now let's start with the easiest first. Oh no, I didn't do that yet, do I? Yeah, okay. So the first problem that you might run into is this one. You think you use a dependency, but you forgot to add it here, and you work with it here, and static code analysis isn't warning you, PyCharm isn't warning you, because the name is defined. The name is the name of the function you have up here, fixture function, but you forgot to pass it. So if I run this test, I won't be happy. Let's close a few windows. Because the function object, my settings, is not equal to the dictionary name Eric. So I mean, this is a very trivial bug to encounter and fix. So that's like an easy start. The next level would be, yeah, let's run this. Let's see here. Here I expect I have to explain at least what I'm trying to do here first. The idea here is, basically taking it more to the extreme, having it like a kitchen sink kind of fixture that is solving all the problems for me, which is then depending on my settings, which is creating the fake settings environment for me, and then passes back the settings. And all I have to do in a test then is depend on this kitchen sink dependency. If that's a good or bad idea, we could discuss also for a long time. But this, you might be doing something. So here you only depend on the my settings. And as you learned about the name argument, you thought, okay, I'll do that also. I have a different name for the fixture here, the function name. And then I set the fixture name explicitly, which is possible for quite a while now already. And my settings is supposed to be the fixture. So if I run this, looks like everything was fine, but actually not everything was fine because my fake environment wasn't really used. And I see this when I uncomment this and run that test again. So that assertion failed because it was actually using my real user settings directory, which is I'm trying to prevent through this. So why did that happen? So it's using the wrong fixture. So, and if I'm, because it's actually yeah, so what I wrote down is no, name doesn't shadow fixture above. So, I would, this is like a bit of a gray area. Because I don't really have the right idea here also what would be the right thing. So I mean, it's really an anti-pattern anyway. One should not do this. I'm just showing these things to show you how you can basically shoot yourself in the foot and what is not so clear. So I define my settings here, and I define my settings here. So which one is the one supposed to be found? The one later defined in the code, theoretically, I would expect if I do this, if I would do it the old-fashioned way, if I would copy that code, then the second one would be it, because of the shadowing of the function object. But that's also an assumption I can't be really sure about, because I can't be really sure about what kind of magic happens here. So I have to be aware of that. And here I see that this one is not found, but the original one, if I do this. So if I comment this out, then it works. Did I run it? My settings. So this is my settings now. I commented that out. So now it should find this fixture where I gave the name my settings like this. So if I run this now, this still doesn't work.
Let's go on. We only
wait a minute. No, yeah. So no, we are in the gotchas area. So this is supposed to be confusing. Let's
do a quick tour of 8, 9, and 10, so that people can see some of those ideas, and use maybe 5 more minutes on this.
Okay, then maybe come back to that. But the reason is that is another problem here, that this fails silently. That's something I wanted to mention at least quickly, because that is really something where I shot myself in the foot in real code. You could think that you can say mark use fixtures here and attach that to a fixture. And this fails silently, which means the fixture is not used if you use that in the fixture context. And it just does not use it without a warning also. There's a bug open to that I think I have a link on in the slides. So this is really something you have to be careful about. Yeah, and those are the 3 things that I wanted to mention anyway. Yeah, so let's have a look at fixture scope. And scope, I think, is a little bit of an not so good name for it. It would be better if we had like lifetime or life cycle for it, because scope is, for me, at least in my understanding, more about the scope of names in which they are in the code valid, so to say. Or, yeah. So we have the function scope, class, module, package, and session scope. The default is function scope, which means the fixture is executed every single time when a test requests it. So always before every test using the fixture, and after it, the setup and teardown functionality of the fixture is being called. If I don't want that, I can raise the scope. So I can go to class, which means all tests in a class, module, all tests in a module, package, that's experimental, but the idea is that it does it for each package if I have my tests in several packages. And session means just once per test run. So first time when it is requested, the setup functionality will be called, and then at the end of the test session, once the teardown functionality will be executed. And one could say here the settings fixture is always the same anyway, so I could set the scope to session here, for example. So this then will only be run once. So now I see in my run output, I only see this output, my settings fixture. I see this only once. And if I would do this would set that back to the default, which is function, and I run both tests, I will see this twice. So that's the basic idea behind scope already. So that's pretty much all you have to know about it. And if you want to know about something new, which is called dynamic scope, which I won't go into here, you can have a look at the docs here. That can set up the scope during setup, depending on, for example, a command line argument that you pass in to manipulate the scope as part of the test run. But that is definitely something advanced. And the standard of Monkeypatch is function scope. The standard of tmppath is also function scope. So if you need higher scope, functionality for these, you would have to do something else also. Yeah, and then let's have a quick look at parametrizing fixtures. So you can parameterize tests. You might know that already. If not, we can have a look at that in a minute. But you can also parameterize fixtures, and that looks like this. You pass in the params keyword argument, and you pass in there a list of parameters that you want the fixture to be called with. And here we see the request fixture that we already saw earlier on. And this request fixture has a lot of interesting functionality, but one of it is to pass you the current parameter that the fixture is called with. So if I create something like this and I request this fixture from a test, that automatically means that this test is run twice, and one time with the fixture where the param is Eric, and with one time where the param is, maybe because I want to test if it works with UTF-8, Bruno. So here then I pass back once Eric and once Bruno. And if I run this, I have every test twice. So it runs once with Eric, once with Bruno, and this also. So this is also a nice way then to, because basically a lot of tests, you write some tests and then you realize, oh, I would like to run pretty much the same test but with different data, or I want to run all these tests that use these fixtures with basically the same fixture but slightly different. Those are the two angles then that you can use. You can parameterize fixtures and you can also parameterize tests. So that is the fixture part of it, and the test part of it looks like this, where you add the pytest mark parameterized decorator to a test. And why I put this also in this little fixture talk, because those are also fixtures. Those are dynamically created fixtures. But if you look at, if you run this with our extra output, you see here the same kind of output: setup, first number, setup, next number, and here then also tear down. So these are dynamically generated fixtures, and what they happen to do is just they pass in the number 1 here and the number 2 there and the number 3 there and the number 4 there with each. So you create, in this case, 3 different tests, and those 3 different tests, they get as their fixture values these parameters that I pass in here. That looks a little bit strange in the beginning. If you haven't seen that, you get used to that. So basically the way how you pass this is just, this is exactly the same like down here. So this is your function definition. And in here you have a collection of the different call details of these functions. So every line here is one function call. And this needs to be wrapped into a tuple so that it can be iterated over. So these are also fixtures, and these are parameterized tests. So, and that was the quick run through, almost already much quicker than I would have liked to, but at least we covered most of the important things here about how fixtures work. And now I will ask Paul how we move on, because now I would have a lot of bonus material basically. Let's just quickly summarize the fixture essentials on one slide. So there are 2 ways of requesting fixtures. There's the parameter in the test function, the definition, and there is pytest mark use fixtures if I don't depend on the object. There's 2 main ways of creating fixtures. So there's the pytest fixture decorator that I can decorate a function with to turn it into a fixture and add it to the pytest run. And I can use pytest mark parameterize to create dynamic fixtures like we saw in the last example. And there's 2 main flavors of fixtures. If you don't need to do anything afterwards, you can just have a normal return, and then it returns the object, and afterwards nothing is being tidied up. If that's what you don't need, then you can use a normal return. But if you want to do something after, then you can use the yield, and then you can read the fixture like everything before yield is set up, whatever is yielded is the object that is being passed to your test, and everything after the yield is the teardown functionality. And then depending on scope, you know how often this is called. Function scope every time, session scope just one time. And PyTest fixture lookup works similar to Python name lookup, only what you have to memorize here is class, module, local plugins, installed plugins, built-in plugins. And fixtures can depend on fixtures, and be careful with, there's a scope gotcha that I didn't mention now. You can only use fixtures with higher scopes. So if you use tmppath with, you can't use them with higher scope. So if you use function scope tmppath in a higher scope fixture, you will get an error. That error will be clear and will be telling you you're doing it wrong. That's the problem. So you need to make sure that the scopes are compatible of the fixtures that you use. And then there's this name quark that I showed you earlier on, which is really handy, which I really like to use. I usually have then a fixture where the function name is, this is what this fixture does. So that's what the function name describes. And then I pass the name argument into the fixture definition. And this is then the object that the fixture is giving back. So that is also a very nice way then of having a clearer description of what is happening and what kind of object is being returned. Yeah, and those gotchas I covered already. So the first one is the use fixture. That is really a nasty one. The link here points to the open bug about it. I think the idea is to have at least a clear warning. And then also the importable test helpers, they should live in an importable package. So if you have testing help functions that you want to be able to access from different tests, don't start using syspath hacks or even put them in conftestpy and then try to import them from the conftestpy by importing the conftestpy. These are really bad ideas that just cause big trouble. So put your helpers in a normal installable importable package, for example, in the production code. There's nothing speaking against having a privately named module that you can use then from your test that is not actually part of the production code, but can be used from the tests. Those are the two things I wanted to mention about this. And whatever gotcha you might face, use the fixture command line functions to see what happens, the ones I showed you, and if possible, run the test through a debugger. Tests are normal code and they should be debuggable like normal code. And if they aren't, maybe you have to do some improvement to do regarding your testing code. So this is now basically what's entering the bonus material. So I take a breather now and let Paul tell me what to do.
We will we'll take some questions and then go ahead and close out because we're a good bit over. So for the bonus material, contact Oliver directly on that.
No, I mean, it's here, so it's basically all there.
Okay.
Link-wise.
So yeah, good point. We shared the link
There's
to
also
those slides.
some more materials here, some more talks, tutorials, books. So enough to go on from here, basically, after this tour de force.
Okay, great. First question, I have an answer to it. I thought I'd give you a chance. Let's only spend like a minute on it. Nick was asking the difference between fixtures and mocking.
Ah.
I can take it if you want me to.
Mocking? Yeah, I mean, you have a problem.
Mocking solves a different problem. You've got something built in outside the control of the tests, and you got to replace it. You might want to replace it with something that keeps track of how it's used, how it's called. In all those frameworks for mocking, let you do the replacing. Fixtures is a little bit different. It's more about kind of setup, stuff you would have put in setup and tear down. And in particular, it's nice because it participates in all the other PyTest machinery about local overrides and parametrize, fixtures that can have fixtures as a dependency kind of thing. Whereas in mocking, you'd have to do all that yourself. Does that sound all right?
Yeah, I was just wondering why the question turned up, and I think I know why, because there is some kind of potentially confusing overlap regarding mocking, which is the Monkeypatch fixture that I showed, because that is
That's a good point.
basically
And they're both
some
kind
kind
of
of
about
mocking.
inputs to your test.
Yeah, but if
Okay,
if you look
Martin
at it,
asks,
what Monkeypatch does, let me just explain that quickly, because Monkeypatch is a form of mocking. It's just not that powerful like magic mock or whatever. But I am mocking the environment. So it's actually, you could say that Monkeypatch is a mocking kind of fixture, but fixtures can do much more than mocking. Yeah.
okay, and we're getting a couple more questions coming in, so we'll speed up a little bit. Martin asks about if you have a fixture where the setup and teardown takes a long time. He said about PyCharm, it's really about PyTest. Can you tell PyTest not to do the teardown and to not do the teardown and to not repeat the setup until the test passes? That's a little bit different than scope session, scope module, etc.
I'm not sure if I understand that correctly. Not doing doing the teardown only when the test has passed, basically. Is that the question?
Right.
There, I think I don't have it in my head now how it works, but I can remember doing something like that quite a while ago. There is a way, I think. There's this
It might be
request
related to yield.
fixture.
So yield gives you control back after the test finishes, and you could do something there.
Yeah, but I don't control when this yield is happening. So I mean, if I'm in the fixture, then I can't control the teardown as such. So I will end up in the teardown section of my code when I used yield. So, but at that point, there is a possibility. I'm pretty sure. I just don't remember the details, but that's where I would start looking. I would look into the request fixture, which has a node attribute, which is basically containing the test. And it might be possible that in that node attribute, there is actually something where I can look up the result of the test if it failed or not. And if it's not there, it's somewhere else. But I'm pretty sure it's possible. So in a fixture, in a teardown code, when the test was run, there is a way to check at that point if the test failed or succeeded. So I would have
Michael asks, how do you parameterize a fixture that is not defined in your code so there's no way to decorate it?
Come again? Sorry.
You have a fixture, it's not under your control, so it's not in your code. How do you parameterize it if you can't decorate it because it's somewhere else? I don't have a good answer for this one because you can't write a fixture that depends on that fixture because it'll execute.
Yeah, I was just thinking you could depend on it and parameterize that depending fixture maybe. That would depend though on what kind of fixture that is and if that makes sense.
Right.
But basically you can't control that fixture without rewriting the code. That's also what I think. Yeah.
Right. Yaroslav asks or mentions he just tested that pytest.mark.usefixtures that usefixtures only works with fixtures defined in a conftest.py. Have you ever heard of that?
So you're saying
Yaroslav,
it does work?
Sorry, go ahead.
Okay, so that is possible. I haven't checked that. So if that gotcha that I showed, if I would put that fixture in a conftest.py, then it would work. That's possible. If he saw that somewhere in the docs, then he knows more than me already, because that's my last knowledge about it. It is I ran into that and it was an open problem, and it's still somehow an open problem, but maybe it's better than before. Now it works in conftest and not. It's possible, yeah.
Okay, last question from Axel. Follow-up question about parameterize. Can I parameterize fixtures with multiple return values of other fixtures? That's a weird chain.
Multiple return values. I mean, multiple return. I mean, as such, my understanding of Python is there are no multiple return values are not possible. Any kind of Python function always returns exactly one object, even if this object is a tuple depending on consisting of 10,000 elements. It's still one object. So there is no such thing as a multiple return values. But you can you can depend on 3 different fixtures, and you can use those fixture values, because if you depend on the fixture, then you get the return value of the fixture, whatever that is, if it's a tuple with 10,000 elements or a class or whatever. So
right.
But I'm not sure if I understood the question correctly.
All right, we'll go ahead and wrap up. Before switching back over to me, Oliver, you got any closing remarks?
Yeah, 1 hour is much too short, and I warned you. I told you this will take much longer, and I knew it. So
yeah,
I wish I had more time to make it shorter. So yeah,
all right.
Thank you. It was fun for me, at least.
Yeah, I will go ahead and switch over to my screen, and let's see. Great. Okay. Before getting into closing remarks, I mentioned this and pasted it in the chat. I did a long form tutorial, 9 steps on visual testing with PyTest using PyCharm. Each one of these, for example, the test fixtures, each one of these has a narrated video and then a tutorial with working code that you gradually walk through. All right, so let me switch over to here. Thanks again, Oliver, for taking the time to talk with us this time about PyTest and fixtures as a follow-on to Talks. If you haven't watched the Talks webinar, it's about, I guess, 3 years old. Still very relevant. Get a chance, go and watch that again. You can find it on our YouTube channel. If any of you have any questions later, please don't hesitate to reach out to us by email or social media. If you'd like to get more information on PyCharm, please go to our website. We'd love your feedback on this webinar, so please feel free to contact us on Twitter or in the after webinar survey. We actually read those things, so fill them in, give us some suggestions. The recording will be made available on our YouTube channel soon. Also, check out our PyCharm blog, where you can find up-to-date PyCharm news. Little hint, check the blog tomorrow. Just saying. In addition to educational resources that we publish there. So for example, the recording of this webinar will be published on our blog in a few days. We'll also provide some extra links and also get that available on Twitter as well. Thank you everyone for joining us. Thank you very much, Oliver, for joining us and presenting PyTest fixtures. I love the topic. I hope all of you have a great day. Thank you.